We're so excited, and I hope you are as well. And it's my great pleasure now to introduce our next speaker, Dr. Nettrice Gaskins. So Dr. Nettrice Gaskins is the Assistant Director of the STEAM Learning Lab, the Lesley University. And she is here with a talk entitled Algorithmic Analytics, Data Science, and 3D Modeling. So culture generates vast amounts of data that represent complex intersections of art, language, narrative, economics, storytelling, and politics. Computers can be taught to simulate cultural art forms and generate results on their own if given simple instructions or algorithms. So in this talk, Dr. Nettrice Gaskins will dive in deeper into the cross-section of data, analytics, and the future of culture through 3D modeling. Super exciting. Thank you so much.
Can you hear me okay?
I can hear and see you perfectly. Sure. Thank you.
Good afternoon, and depending on where you're calling from, I'm going to talk a little bit about the work I've been doing for the last few years, including leading up to my current position at Lesley University. I'm going to share my screen in just a second. Let's see. Hopefully folks can see this. I'm putting it in present mode. Okay, so this is kind of some ideas kind of put together, but basically there's a history of data visualization, including W.B. Du Bois, who was an activist, writer, sociologist, historian. He exhibited a number of graphs, charts, and maps that illustrate the color line and shine a spotlight into how Black Americans were living at the time. So at the turn of the 20th century, we have an example of data visualization, in this case, coming through the Paris Exposition and W.B. Du Bois and a bunch of other researchers that he was working with. Today, researchers can sort of draw from big data, which is a growing field that uses different data analytics and methods to extract value from data. So big data, you draws from text, you can draw from images, audio, video, and more. So the idea of big data being around only in the last 10 to 15 years, maybe a little bit longer, in terms of the idea that there's these vast stores of information that are available for people to be able to pull from, to use and make meaning of in some way. So this, when you think about W.B. Du Bois, it was working with a data set of a specific type at the turn of the 20th century. And now in the 21st century, we have access to even more information and data available to us, even at the click of a mouse. So data scientists are, they've created algorithms that sort and collect specific data and tools, such as machine learning, which I'll talk about, that help in developing insights that would be difficult to extract by other methods. So there's sort of three main areas to think about in this process. There's the data, which is unprocessed fact, values, text, sound, or picture. There's the information, the data that's been interpreted and has some meaningful inference to users. And then knowledge, which is inferred information that results in awareness or concept building. So this idea that, automation, machine learning, different subsets of artificial intelligence, in addition to those, emerging tools that mix and sort of merge different computer technologies that are based on big data. Come back here. So now we have this kind of, here's a wordle, but there's all these different concepts and ideas and inventions and innovations that come out of this idea of using big data and artificial intelligence, machine learning being another one of them, deep learning being another, fitting into robotics, fitting into blockchain and economics, and just so many other different areas. And it just kind of goes on and on. So in this cloud of concepts and frameworks, it's kind of, you pick one area, you kind of specialize in that, or you pick a subset and sort of work in that in emerging fields. So my interest in this is I connected to what Du Bois was doing in the turn of the 20th century, which you can see on the left, with these ideas of using different tools and cultural data to interpret and visualize information. So some cultural art forms, in this case, quilts from Gee's Bend, Alabama, are amenable to algorithmic design. So this is where Tufty, and he actually has an image quilt program that pulls cultural artifacts together and creates these kind of quilted looking data visualizations of data sets. So I found a direct correlation between Du Bois's work and this particular work that Tufty was doing. And then, although people wouldn't know it unless I talk about it, my entry point to algorithmic design and data analysis and data science comes through James Brown. There was a scholar named James A. Sneed who he's long gone now, but when he was at Yale, he did a lot of research into something called repetition and the cut, which he describes as a way in Black cultural production that people sort of disrupt a sequence. They disrupt a sequence and it returns back to the original, at some point, the original sequence, and then changes again. So the way that he describes Code Sweat in his essay is algorithmic. He's basically, and it was an aha moment for me to realize that even in cultural art forms, algorithms are there, and you can actually use that to explore in terms of computer science and computing and computational thinking. So I took this idea. This is a snippet of Sneed's essay where he talks about James Brown's Code Sweat. He describes it actually as notation, as an algorithm. So I took this information, I took the actual song Code Sweat, and I fed it through my music visualization program, did some data analysis, and produced what you see on the right, which is compared to the Gee's Bend quilt that you saw with Tufty. And you can see that there's a similarity in the design. So then once I had the two-dimensional image, I was able to extrude it and create a three-dimensional model, which was then able to be fabricated using wood or cardboard or even 3D printing. So this idea of moving from something that's a song or music into something that's physical or something that can be projected was something that I was really doing both as a professional, working with students and various people, and then also as an artist. So more recently, I went back to, I was challenged by the math department, Center for Math at Leicester University to look at data. In that case, it was US Census data. And was there something that I could do to sort of create an engaging activity, project-based activity around taking the data and making it into something that was project-based? So in this case, this is looking at lionfish, but I started with US Census data and was able to move it all the way over to create a visualization and eventually a 3D model of data from the US Census. So there's a sort of meaning-making activity in that you're understanding the data in different ways. So you're looking at the visuals, you're looking at maybe hearing music and video and animation, and all that is sort of telling you something about the data in addition to looking at the spreadsheet. And then this is the example of the US Census data. So on the left is the visualization, the music visualization of the sound waves from the data. And then on the right is the detailed three-dimensional model that can then be fabricated that came out of the data from the US Census. See, okay. Then I became a member of Kaggle. Kaggle came out of Google, and it is a community of data scientists and machine learning specialists. And so there are people just sharing data sets all over the place. So this one was for Pokemon. So I found some data, found a spreadsheet that was in the right formation and brought that into software to create a visualization in terms of sound and visuals to bring that into my program. And then I was able to, in this case, have a Pokemon character Pikachu dancing to the data. So the sound of, what is the sound of data? That was something that was really fun. It was a way of sort of also seeing what happens when you begin to have data be represented by three-dimensional models and images and art and music and so on. So alongside of that, I was really looking into computer vision. And you can see here on computer vision is a sort of comes out of artificial neural networks that learn using large amounts of data. So deep learning or deep dreaming is a subset of a growing computer vision field. So deep dream was something that Google came out with in like 2015. They released the code to the world in 2015, and people began to create platforms for people to be able to explore and start to experiment with deep dreaming, which is this deep learning idea in computer vision. So the image that you see here is of a jazz artist, but it was originally a photograph, has gone through a series of iterations to become a painting because of the deep dream and the algorithmic process of creating this work. And here you can see that deep learning uses algorithms to identify objects, process data, and make decisions, and complete complex tasks, and does this in seconds. So you can see on the left, there's an input image, and then on the right, you see the output. So there are all the stuff that happens in between is using algorithms to identify the object, process the data, make some decisions, and then you can see that the result is a new type of image, an image just drawn in the style that was, in this case, uploaded to the system. So it goes through a kind of a dreaming process, a learning process in order for it to become, and in this case, a different type of image instead of just a photograph of a mug, coffee mug. And then, and you can actually go further than that. So the aim with deep learning or deep dreaming is to enable computers to learn algorithms and specialized methods to interpret what the computer sees. This is an earlier experiment also with deep dream, same as before, but I was actually teaching AP computer science principles to high school juniors and seniors. This is one of my students, and teaching them, because they all majored in the arts at this particular high school in Boston. And they were all very interested in how art could be, how computation and art work together. So that's where I discovered Deep Dream and discovered machine learning and and the whole process of collaborating with artificial intelligence to produce different results. So, whether it's in this case an illustration or a portrait, it can also be a book cover. Actually, I've done book covers. I've done magazine covers. Some of it's been produced in terms of artwork. And others, it's also been in virtual reality, mixed reality in terms of technology. It kind of spreads out into all these different platforms and connections. And going back to what I was talking about with earlier is by understanding kind of where Du Bois was in the turn of the 20th century, thinking about data, thinking about how to represent it visually to tell a story, and also to sort of represent what's happening at a particular moment of time. And this is sort of now where we're at today, where we're able to use tools like Deep Dream to Deep Dream and others to be able to represent our world and do that in interesting ways. My entry point for learning machine learning, learning myself machine learning, was through collaborating with AI to produce images that you saw here. And then I began to understand the process better. At some point, I began to create one Deep Dream image per day for 365 days to see what would happen once I did that. And actually, my images actually improved. So my imaging improved. I understood the system better. I understood how the system worked. So I was able to sort of collaborate with AI and then understand how AI works. So then AI was learning from me, I was learning from it, and the images improved. So there was actually a change in the work over time, in this case of a period of a year, that what became something that was happening on its own, where more people became interested in the work. I had to create a website for people interested in the work. It got exhibitions all over the world, including in Italy. And it's been that piece plus the educational piece, which I'll talk about in a second. So at the Leslie STEAM Learning Lab, we have, the whole purpose of the Leslie STEAM Learning Lab is to, let's see if I can get it to open a page up, is it's sort of a maker space in the Graduate School of Education to provide students with the chance to play with different techniques and methods. Usually teachers in training, pre-service teachers, but often partners in the community and collaborations such as, or partnerships such as the STAR initiative with Biogen Foundation. So we've been tinkering with STEAM and doing projects that way. The data science, the Sound of Data Science project that I want to talk about came from this sort of support. And so we, people can come here, especially now there's remote learning happening. A lot of teachers are looking for projects that they can do with their students who are at home and can't physically be in a classroom. So it was really important for me to be able to offer, work with Leslie and offer this project for teachers in training. And then also on the education side is to be able to create the data sets. The Sound of Data Science became an actual lesson plan where you can, anyone could go to the Instructables website and go through a project-based experience of conducting a mini field study using US Census data and figuring out how to extract key information from the data. And so this is, of course, for students, high school students, possibly middle school students, but also even college, to be able to understand data in different ways. So I provided some data sets from the US Census for people to be able to use in the Instructable. They make sense of the data first. And this is for people who are just learning about data science. And then they're looking at, in this case, the New York City Census data set and the US Census data, demographic data set for the country as well as for New York City, and doing some comparisons and asking questions. The next step would be turning the data into sounds, and that's the part of the data analysis that I sort of been playing around with for a while, and using open source or free programs for people, for students and for teachers to be able to create. And you can see here, this is using the census data, and that data is now is able to play music. So this is a little demonstration about how to use the software, which is called Two-Tone. And you can actually, for every data piece of information, you can attach an instrument and compose songs based on what the data is giving you using this program. So that after that, they're able to produce a sound wave as a visualization, and then bring that sound wave into a different program and create visuals that can then be made into models. In this case, you can look at another version of visualization of the data, of the census data. And then as a final step is to make that model, the visualization, into a 3D model, which you can see here. That can be fabricated, it can be made into an object, it can be made into other things. There can be extension activities. This is an array. When we think about computation, we can push it further beyond what we were doing before, and we can actually make this into tapestry or things that can be fabricated as on cloth. So I was thinking about digital embroidery machines and things that could also do this. I know that Google had a project called Project Jacquard, which was taking some, bringing artificial intelligence into fabrication and textiles and being able to produce prints. This is a different way of doing that using data. So at the end of the day, you can just keep going. So here's the lionfish data that I was working with an organization in the little Cayman Island, and kind of doing research of coral reef research, and also some lionfish research. And we dissected lionfish. We looked at lionfish. There was sensors put in the lionfish to gather, since they're predators, and there's really They were invasive. We wanted to study how far out they went so the sensors would track and some data, create data around where the lionfish would go out. And we thought, how can we visualize this? How can we better understand this data using visualization and modeling? So there's different ways to sort of take this once you were able to sort of come into there. So come into this area, this field of data science. So I don't, this is kind of another example. And then the final example is because of the popularity of the algorithmic, because of the popularity of the deep dream images, I created a website to actually, as a gallery and eventually a store, to show what can be done with artificial intelligence and data sets. And so this is that work here. So you can see some of the images you saw before, but this is just taking different images I've taken, images from archives, from film, and actually producing and using AI to produce a new type of image with a different aesthetic that has only been created because of the collaboration with AI. And so that's pretty much what I know there might be some Q&A or not, but I definitely wanted to, and you can see in my background, it's also one of the images from Deep Dream. It's from a FDR era film, WPA from the South. And it was also, what you're looking at is something that was a collaboration with artificial intelligence. And it's been an interesting journey to go from educator, artist, and designer to data scientist. So I don't know if there are any questions or if people have any anything they want to know more information about, but I wanted to leave a few minutes if that was possible.
Wow, thank you so much. That's mind-blowing. Wow, I'm blown away. And I think some of our audience as well, just commenting on how gorgeous and beautiful and amazing all those images are that you're showing. Truly wonderful. I will definitely be having a look on your website. And I believe you mentioned it's also a store, so some of the images are available for purchase.
Because in Massachusetts is a shutdown, so there's only essential services at the moment because of the pandemic. So I can't get around to all the places I could. So once they relax some of those rules, the store will come back up with the galleries on the site.
Thank you. Can't wait. Britt is asking, what advice would you give someone who is interested in this field? So how to get started?
I came at it first I came through it as a teacher. And then it was a teacher of students who majored in the arts, in this case, high school students. And then I realized as an artist, I wanted to go further with it myself. So that was my entry point. So it's a little bit non-traditional. As a background, computer graphics was my, first it was computer graphics that became art and technology, that became digital media. So I did study it from on a scholarship level, but not as an artist or not in application until I started to teach. So teaching was my way in, and then art became a way in which I expanded beyond that. And that's kind of how I became a data scientist. It's somewhere in between academics and so on.
Fascinating. I'm actually personally wanted to ask a question about the digital embroidery. Is it available like commercially? Like I have 2 kids and I just think, oh, it would be amazing to get like, some kind of 3D model or a quilt or something, but with the sounds of my with my children when they're learning how to talk, and I just think that's so beautiful. So I don't know if it's I will find you.
Yes, the software that I'm using, I'm being very particular because I want to be able the students to be able to have access to it. So it has to be something that students can do at home, because we are in a situation where students aren't in the classroom physically. So it has to be something that they can have access to at home. So I'm using open source and free programs for students to be able, and teachers to be able to explore. The Two-Tone app is free. It takes data sets from everywhere. And as long as it's in the right formatting, it kind of lets you know up front what you need to upload. You can just compose music, and then you can add, there's a microphone, so you can add voices, so there can be voiceover and storytelling along with the music. What's the data mean, all that kind of stuff. And then when you have that MP3 file, you can play it as music, or you can bring it into the visual side and do the textiles and do the modeling and do the other types of things that can happen once the data has been visualized. And then,
wow, I am super excited. So the free app is called Two Tone. Is that
yeah,
number two or T?
Yeah, TWOTONE. It's kind of it's definitely something that I really think is really easy to sort of figure out. The tricky part is just the data. The data set has to be a particular format. It has to have, the headers have to be a certain way. But once you get the right data set and the right file, then you're able to compose music fine with it. And it's pretty interesting to see. It's also interesting to see the visuals, to see how, like once I saw the array, I realized you can use the arm of the digital embroidery on your sewing machine and be able to create that as cloth, as something that's real and tangible, which takes meaning, making sense of the data into a different realm.
That's so cool. Thank you so much. I'm just loving the way that all these different things can be combined: data, music, art, history. It's truly wonderful. Thank you so much, Dr. Gaskins.
Sure.
Does anybody else have a question? We have a minute or so time. Noor, this is awesome. Thank you so much for an amazing presentation. I think we've all been blown away by the possibilities that are out there. And yes, our recordings will also be available on our platform in a couple of weeks' time. There's some amazing information out there. So if nobody else has a question, I would really like to thank Dr. Nettrice Gaskins for your time today and for participating in the in our virtual summit, Diversity Reboot 2020. Any last words?
Well, thank you. And hopefully people will dig into this a little more, because I think it's really fun, but it's also very educational. And also it's kind of where we're going with data science today. It's really trying to push the boundaries and to learn more about the data, as opposed to just having it sit up in the cloud somewhere. It's to pull it down and make it real for people.
And accessible. And
absolutely.
I mean, also some people, they're really not into the numbers, but when you can combine the numbers with like art and music, it just becomes so much more holistic and just interesting for everyone. So thank you so much.
Yes, thank you.